Okay, this is the first videos for chapter 7.4. We're going to talk about some basic concepts of probability. The first one we want you to know and maybe first remember that we have talked about unions and intersect, right? So we use this U-shaped symbol to represent unions. And the keyword for that is or. It means either or, and this represent intersect. The keyword for that is and means we are going to look for the overlapping part. Okay, so you need to remember that. And for this particular one, we started with the union rule for probability. So the union rule for probability, remember we say we can use like a rectangular shape to represent the universal set. And if we have two sets in here like that, they don't have anything in common, those kind are called mutually exclusive. So if we're looking for A intersect B, so if we're doing the intersect part, A intersect B, the overlapping part, they don't have anything in common, right? So that would be an empty set. But if I have two boxes, if I have another universal set that the two sets overlapping with each other, one is A, one is B, so I can see A and B overlapping each other. So if we look at this set, these two sets, they are not mutually exclusive, right? So when you do A intersect B, this time is not going to be an empty set, right? So over here, the first one we're going to talk about using this picture. So we just talk about intersect, but how about union? The union rule for probability. So if we have two things, which is E and F, when you talk about a union, probability of A union B will equal to the probability of A circle plus the probability of the B circle, but then you have to subtract what they have in common. Okay, so that one is important and we're going to need to use that today. This means if they're mutually exclusive, then you don't have anything to subtract, but if they are overlapping each other, you have to subtract that overlapping part. Okay, so let's try with the first example. The first example says if a single card is drawn from an ordinary deck of cards, meaning 52 cards, right? Found the probability that it will be a red or mean union, right? Either or, right? A face card. So we will say probability of red or a face card. So it's kind of important to know those keywords, right? This is or. So I'm going to need to get probability of red cards, adding the probability of the face cards, and then subtract anything they have in common, right? It's both red and face card, right? If they have anything overlap, which I think they do. Alright, remember we have 52 cards. And how many of them would be red? 52, half of them are red, right? So, and then adding face cards. Face card means jack, queen, and king, right? And each of them should have 4 So 3 times 4 is totally, you have 12 face cards out of 52, and then we need to subtract what they have in common. So still out of 52 face card, you have Jack, Queen, and King, right? So 3 types and totally 12. Half of them would be red, right? So if it's red and also face card, it would be half of the 12, so it's going to be 6. So if I add 26 plus 12 minus 6, it's going to be 32 out of 52, and then we can reduce it by 4. So your final answer for that would be 8 out of 13 times. You're going to draw a card that is going to be either red color or a face card. Alright, so that's number 1. Number 2, they say you're rolling 2 dice, so I could go ahead and list this out for you. Maybe that's helpful, hopefully. So this is the first dice you roll, second dice you roll. You can have 1 1, 1 2, 1 3, etc. right? And then this one would be, so this one is the result of rolling 2 dice, and this one would be the sum of rolling 2 dice. So you don't have to list them by yourself, like 1 and 1 you get a 2, 1 and 2 you get a 3, etc. right? So those are your results. You may need that for your homework. Some of the homework question may ask you that. So the question asks you, the first die show is a 2, or, so again, or mean union, right? The sum of the results is 6 or 7, so that's the mess. So A, we are going to find probability of first dice is 2, and sometimes they will say this is A and the other one is B, and then or, so we use the union side, the sum equal to 6 or 7, right? So using the same rule, we're going to say, okay, I need to add the probability of first dice is 2, adding probability of sum equal to 6 or 7, and subtract the overlapping part, right? Subtract P. I don't have enough space. So first dice equal to 2, intersecting sum is 6 or 7. So a lot of time your book will say let this be A, let this be B. So P of A plus P of B equal to P of A intersect B. Alright, so let's look at this. First dice is 2, so 2, first dice 2 is over here, right? So 1, 2, 3, 4, 5, 6, right? So you have 6 out of how many do we have? Like 6 times 6, so totally we have 36 results here, right? Adding 6 or 7, so 6 or 7 is going to be, I think this is 6, 6, 6, 6, 6, and then 7 would be, these add up to 7, 7, 7, 7, 7, 7. So 2, 4, 6, 8, 10, 11. So you have 11 out of 36 would be the sum equal to 6 or 7, or you can see here like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, and then I need to subtract the overlapping part, right? So I don't know if you can see it, but the overlapping part is both highlighted yellow and green. So that's 1 here, and then there's 1 here. So you have 2 overlapping results, right? So minus 2 out of 36. So 6 plus 11 is 17. 17, need to subtract 2 would be 15, right? So 15 out of 36 is my answer, and then both of them can be divided by 5. So final answer would be 5 out of 12. So probability of either the first dice is 2 or the sum is 6 or 7 is 5 out of 12. And you can use that to convert it to decimal number or percentage if you want to, okay? Alright, the next one is about the complement rule. So I'm just looking at this. It's kind of bothering me here, so I'm going to cross this out. So when I send you the file, probably this will be gone. Okay, so over here, complements. Remember, complement, the keyword is not, right? So not A. Compare A sets with the universal sets. So I can say if I have a universal set and this is E, so this is set E, so I would color in the circle E, right? And then if I want to draw not E, so the symbol would be like this, right? Or you can use a bar on top of this, or you can use like a little C over here, mean complement. So I can have my set E, but I want not E, so it's going to be outside of E, right? So the properties say if you combine this and this, it would equal to the universal sets. So probability of E plus probability of not E will equal to the universal set, right? Or you can say E union not E will be the sample sets, basically. Alright, or you can say it's also true that the two should not have anything in common, right? So if E intersecting not E, you should get an empty set. So this is true also, and this is true, and this is true. Okay, some more property. They said this is sometimes very useful if you need to find probability of E or probability of not E, and you know the other one, because you can use 1 subtracting the probability of not E. So probability of E set mean the whole thing subtract not E, or you can use if you need to find probability of not E, you can use the whole thing subtracting probability of E. So they complement each other, okay? So those are representing the rule for complements. So over here, let's say, if a fair dice is rolled, what is the probability that any number but 5 will come out? So I want to find probability of not 5, right? So it's easier if it's a rolling a dice. I have 6 items in the sample space, right? 1, 2, 3, 4, 5, 6. So it's easier for me to find probability of rolling a 5, right? It would be 1 out of 6 times rolling a dice will get a 5. So if I need to find probability of not 5, this means like E is 5, rolling a 5, right? Probability of not 5, that would be 1 subtracting 1 over 6, or you can say 6 over 6 minus 1 over 6, so it would be 5 over 6, right? So this is probability of not rolling a 5 is 5 out of 6 times, alright? So let's see example number 4. If 2 fair dice are rolled, found the probability that the sum of the number rolled is greater than 3. So we can use the table above, right? And some of your homework may ask you to do it. Use table above. So instead of trying to find probability of the sum that equal to, they say greater than 3, right? So not 3, but 4, 5, 6, 7, 8, 9, 10, 11, 12, because you're rolling 2, right? So if you roll 6 and 6, you have 12. So there are all the possibility of greater than 3. So if we can use the complement rule, that we can do 1 subtracting probability of sum equal to 2 and the sum equal to 3, right? Sorry. So those two are much smaller numbers. So if you look at those table, sum of 2 you just got 1 out of 36, sum of 3 you get 2 out of 36. That's it, right? So those numbers are a little bit easier to manage. So basically just 1 subtracting, you can add them or you just subtract both of them. Either way would be okay, because if you distribute a negative, it would be that, right? So sum of 2, you only have 1 out of 36, and then you need to subtract 2 out of 36. So basically 36 out of 36, subtract 1 out of 36, subtract 2 out of 36. So it's like subtracting 3, right? So the answer would be 33 out of 36. If you divide 3 both top and bottom, you got 11 out of 12. So 11 out of 12 times is going to be the sum of rolling 2 dice. The sum would be greater than 3. All right. So next part, we're going to talk about odd. So odd. We have 2 types. One is odd in favor of an event. Will be the ratio of P of the E to P of not E. And so the odd in favor of like an event would be in favor of probability of E would be probability of E would be probability of E over probability of not E. So and P of E cannot equal to 0, right? So that's one thing about the odds. You can do the ratios, but sometimes it's going to be presented to you like this. So if odds in favor of event E are m to n, so a number to another number, then your probability of E would be m over m plus n. Probability of not E would be n over m plus n. So we're going to do some example and let you check it out. So example 5 says, suppose the weather forecast say that the probability of raining tomorrow is going to be 1/3, found the odds in favor of raining tomorrow. So we want the odds in favor of raining, right? So we're going to need to write odds in favor of raining. So it's going to be probability of it's going to rain over probability of it's not going to rain, right? Okay, so if the odd for raining is 1/3, the other one would be 1 minus 1/3, right? 1 minus 1/3, I think you can do it in your head, it's going to be 2/3, right? Remember we can like cancel like the denominator like that, so the final answer is just like 1 over 2. So, or you can do the division and flip it and stuff like that, but we did that in the beginning of the semester. So the answer for the odd is going to be, in favor of winning, is going to be 1 to 2, or you can write that as 1 to 2 like this. Alright, so they're pretty short, it's not too bad. Number 6, package delivery. The odds of a particular package will be delivered on time are 25 to 2. So they are given to you like that. Find the probability of that package will be delivered on time. So we're trying to find the probability of deliver on time, right? So they have in favor is 25 to 2, right? So 25 is in favor, and then we need the sum of them. So it's going to be 25 plus 2. So together we have 25 out of 27. So the probability of that is going to be delivered on time is going to be 25 out of 27 times, okay? Okay, the next topic, so we talk about odds, which we will write that as odd in favor of E would be P of E divided by P of not E. If odd in favor of even E are M to N, then probability of E would be that, not E would be that. Okay. So the next topic is probability distribution. So a table lists each possible outcome of an event and experiments, and its corresponding probability is called probability distribution. Make sure your sum of all the probability would be 1. So we want you to build a probability distribution table of the sum of rolling 2 dice. So again, you probably need that table from the last page to build that, because we are rolling 2 dice, so you're gonna need this table. So I'm gonna write that this is represents sum, and then probability of the event is here. So my sum, the smallest sum is 2, right? So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we will write the total here, okay? So this is for probability distribution for sum of rolling 2 dice, alright? So rolling a 2 only happen 1 time out of, you have totally 36 different result, right? So 1 out of 36, and rolling a 2 would be just 2 results out of 36, right? And then we just like figure it out using the table, okay? So take a minute and write that down. For 4 is 3 out of 36, for 5 is 4 out of 36, for 6 is 5 out of 36. It looks like there's a pattern. And then 7 is going to be 6 out of 36, and then it drop back down like 5 out of 36, 4 out of 36, 10 is 3 out of 36, 11 would be 2 out of 36, and then 1 out of 36. So totally, if you add up the top, it should be 36 out of 36. So it equal to 1, right? So probability distribution table is built like this. Okay, last example. Example 8 is about clothing. Susan is a college student who received heavy sweaters from her aunts at the first signs of cold weather. Susan has determined that probability that a sweater is wrong size is 47% of the time. The probability of that is the loud color is 59% of 0.59. The probability that it is both wrong size and a loud color is 0.31. So you have to be careful, like these two has some overlapping part together. So a lot of time we will say use the number to build a Venn diagram. Okay, so I'm gonna say the W would be representing wrong size, and then loud color we can use out, and then both would be 0.31. So I can have a universal set of sweater from end. Okay, and then one of them representing the wrong sides, the other one represent the loud color, right? And they said the one overlapping is 0.31, so I can use that number, 0.31 here. So I can say probability of wrong color intersecting wrong size intersect loud color is 0.31, right? So that's the overlapping point. How about probability of wrong size only? So that part will be, you need to use the wrong size probability, subtracting the overlapping part, both wrong and loud color. So it's going to be that 0.47 subtracting 0.31. So that will be 0.16. So 0.16 is here, and if you add 0.16 and 0.31, you will get back to 0.47, okay? And then we are going to do probability of loud color only. So just this part. So we use probability of loud color subtracting the overlapping part, right? Wrong and loud. So together is 0.59 subtracting 0.31. We are going to get 0.28. So we have 0.28 here. So again, the 0.31 and 0.28 together will get you back to 0.59. Because if you add this number, and this number is already more than 1. So that's like not correct. There's some overlapping part here. So if I know this section, this section, this section, can I find out the section outside? What number is that? So I can, is that what the first question is? Found the probability that the sweater is correct size, so it's outside of the wrong side circle, right? And mean I need to overlap, it need to be both, not loud color. So the first question mean what is the outside probability? Not wrong, not loud color. So for the A part, this is just to set up the Venn diagram, right? So for the A part, let's do it here. A part say probability of not wrong and intersecting N, right? Not loud. So this would be, you can use 100% subtracting the two circle, right? So you can do 1 minus 0.16 minus 0.31 minus 0.28. So after you subtract that, you should get 0.25. So 0.25 go here. So I can finish my Venn diagram. And 0.25 or 25% of the time, the sweater is correct in size and not loud color. Are we okay? So this is A. Alright, so we also need to look at B. B say found the probability that the sweater is correct in size or, so this time is or, not in loud color. So either way, so either just outside this circle or outside this circle. So that's like if it fit one of these conditions, that's okay with us. So probably the percentage would be higher, because the last one is going to be need to fit both, but this one just one of those conditions. So B say probability of not wrong sides or union not loud color. So if they fit in one of the conditions, that would be okay. So they say there is a theory, say it's basically the same as intersecting the complements. So we can say that not wrong, we got 0.25 for sure because it's outside, plus 0.16 plus 0.28. So like trying to say, if it's not both of them, we are good, right? So the only thing will get us in trouble is the overlapping part. So you can figure it out like that, and this is actually the same. That's the theory. Say this like P of not W union not L is the same as P of W intersect L complements. So they say you can also do 1 minus 0.31, which is the overlapping part here, will equal to 0.69, and this also will equal to 0.69, which means 69% of the time you will get the sweater that is correct size, or either way, not loud. Alright, so this is 7.4.